In this session, we'll be looking at the AQA Trilogy past paper. It's the Foundation past paper and it's from the year 2018. Also, please remember to download the past paper from the description below and have a go before going through the answers. There are many different energy resources. Which two energy resources are renewable? So renewable are ones that will not run out. So the correct answer would be biofuels and geothermal. Some non-renewable energy resources are more reliable than others. So non-renewables are things like coal, oil and gas. Which two statements correctly describe a reliable resource? So if it's reliable, that means it will be predictable. We will know how much energy is being given out. Figure 1 shows a wind farm, and the wind farm has 1, 2, 3, 4, 5, 6, 7 windmills. A total output is 19.6 megawatts. All of the wind turbines have the same power output. What is the output of one turbine? So we would do 19.6 divided by 7, and the correct answer would be 2.8. There are two reasons why people might not like having wind turbines near their homes. So first of all, it's causing visual pollution. They don't look nice. And the second most common answer would be that it gives noise pollution as well. They are quite noisy. But also you could think of things like they will affect flying wildlife like birds, so they could be dangerous to those, as well as it could lower house prices. Figure 2 shows the electricity generated by different energy resources in the UK. The total amount of energy generated was the same in 2014 and 2015. So we've got a pie chart of 2014 and 2015 showing the different types of energy resources used. Explain the environmental impact of the changes. So we can say the percentage generated by coal was decreased by 8% in 2015, leading to less carbon dioxide released into the atmosphere. You could also say that there would be less acid rain due to pollution in the atmosphere. Secondly, we can say the percentage of renewables has increased by 6% in 2015, leading to less greenhouse gases released into the atmosphere. You could also say that the percentage generated by nuclear has increased by 2%, again leading to less carbon dioxide or greenhouse gases being released into the atmosphere. Figure 3 shows a mobile phone being recharged by a portable power source. Why does the battery in the phone need recharging? So remember, batteries have chemical energy, which means the chemical energy in the battery has reduced. The power source provides a current of 1.86 amps at a potential difference of 3.9 volts. Calculate the power of the power source and use the equation given. And we also have to choose the correct unit. So the correct units of power are watts, so we'll put a W in there, and the calculation would be power equals potential difference, which is 3.9 volts, times the current, which is 1.86, and if we calculate that out, the power works out at 7.254. A student needs a new power source. Figure 4 shows 3 different types of power sources. So we've got compact, large and high capacity. The student chooses the large power source. Suggest why the student chooses the large power source. In this question, we are simply going to state what we see from the data. So we can see that the large is twice as heavy as the compact charger, but it can give 5 times more charges. Secondly, when we compare the large to the high capacity, it has 1/3 of the mass, but gives half the number of charges. So for the same mass, it would give more charges. Figure 5 shows a girl on a skateboard on a semicircular ramp. The height is 4 meters and the mass of the girl is 50 kilograms. We've got to calculate the gravitational potential energy and we've got to use this equation here. The gravitational field strength is 9.8 newtons per kilogram. So using our equation, we would have the mass, which is 50 kilograms, times gravitational field strength, 9.8, times the height, which was 4 meters. And if we calculate that out, we get an answer for the gravitational potential energy of 1,960 joules. The girl has a speed of 7 meters per second at the bottom of the ramp. We've got to calculate the kinetic energy of the girl at the bottom of the ramp. And kinetic energy, we're given the equation here, is a half times mass times her velocity squared. So if we put in our numbers, we will have 0.5 times the mass of the girl, which is 50, times the speed squared, and we were told her speed is 7 meters per second, so it's 7 squared. Now, when you're putting it in your calculators, do the 7 squared first, times the 50 times the 0.5, and we get an answer of 1,225 joules. Not all of the gravitational potential energy has been transferred to kinetic energy when the girl starts to go down the ramp on a skateboard. Which two statements explain why? So first of all, some energy is always going to be wasted, for example, as heat energy. Also, the gravitational potential energy of the girl at the top will not be exactly zero. Explain how lubricating the wheels of the skateboard can increase the speed of the girl, and use ideas about energy in your explanation. So the lubrication will reduce how much friction there is, so that means less energy is wasted. Also, this means that more of the gravitational potential energy is being transferred to kinetic energy. Some ceiling lights in the home are connected to the mains by a 2-core cable. Figure 6 shows a ceiling light. So we can see here only 2 cables. Suggest why some ceiling lights do not have an earth wire. Due to the case being made of plastic, that means it's double insulated, so there is no chance of an electric shock. Write then the equation that links charge flow to current and time. So charge flow is current times time, or you could write it as words, that's fine as well. There is a current of 2.95 amps in one of the copper wires for 60 seconds. Calculate the charge flow through the wire. So using our equation, the charge flow is going to be 2.95 amps times 60 seconds, which gives us an answer of the charge flow being 177 coulombs. Now, if you did not put anything here and you multiplied the current by the times there, that could help you recall that equation. Figure 7 shows a current potential difference graph for a piece of copper wire. Draw another line on Figure 7 for a wire with a different resistance. So all you need to do is take your ruler and draw a straight line with a different gradient. Some fuses have a thin piece of copper wire that melts if a current is too large. Draw the symbol for a fuse. So a fuse is a rectangle with a straight line going through it. It's important to know your components. For the next question, we've got to describe how the movement of copper particles in the wire changes when copper melts. So we've got to say what the particles start off as and what they change to. So the particles in the copper wire vibrate in a fixed position to start with, but when it starts to melt, they're able to move freely. Now for the next question, an old copper wires are melted when they are recycled. Calculate the energy needed to melt 500 kilograms of copper at its melting point. Specific latent heat of copper is 200 kilojoules per kilogram, and you have the equation to use on the handout that you have in the test. So have a look at that, and you will see to work out the energy is going to be the latent heat multiplied by the mass. So the latent heat here is 200 kilojoules per kilogram. So if we convert that to joules per kilogram, that's going to be 200,000, because there's 1,000 joules in a kilojoule. So using our conversion, we would have 200,000 kilojoules times the mass in kilograms, which is 500 kilograms. And if we calculate that out, we get 100 million joules. If you did not do the conversion, you would still get 2 marks out of 3. Radioactive nuclei can emit alpha, beta, or gamma radiation. Which type of radiation is the most penetrating? So that means which type of radiation is the best at going through things, and that would be gamma. Which type of radiation is the most ionizing? So that means which type of radiation is best at knocking electrons off other atoms, and that would be alpha because it is the largest particle. And then which type of radiation has the longest range in air? So that means it will travel the furthest in air, and again that would be gamma radiation. When radioactive isotopes in the Earth's crust decay, they release energy. The decay causes the heating of rocks in the crust. Figure 8 shows the decay of uranium-238 into thorium-234, and we have our equation there. Complete the table to show the number of neutrons and protons in the nucleus. So what we've got to remember is the mass number given here is the protons plus the neutrons. So for uranium, if we have 146 protons, we would do the calculation of 238 take away 146, and that would give us an answer of 92. And then for thorium, we would do the calculation 234 take away the number of protons, which is 90, and that would leave 144. Geothermal power stations pump water through heated rocks. The temperature of the water increases from 20 degrees Celsius to its boiling point of 100 degrees Celsius. Calculate the change in the thermal energy when the mass of water is heated to 150 kilograms. Specific heat capacity of water is 4,200 joules per kilogram per degree Celsius, and you have the equation in the equation sheet. So the change in energy is going to be the mass times the specific heat capacity times the change in temperature. And if we put our numbers in, that means the energy is going to be the mass, which is 150 times the specific heat capacity, 4,200 joules, times a change in temperature. So if it's gone from 20 to 100 degrees, that's an 80 degrees Celsius change. And when we calculate that out, the energy is 50,400,000 joules. In this question, we have two models of the atom. So we've got the plum pudding model and the nuclear model, and we've got to label the different parts. So the negative parts are the electrons. The whole thing is the atom. The middle of the nuclear model is the nucleus. And the circles are the orbits on which we have the electrons. Now we've got to explain why the total positive charge in every atom of an element is always the same. So what we can say here is that every atom has the same number of protons which are positively charged. The results from an alpha particle scattering experiment led to the nuclear model. The alpha particles were fired at a thin film of gold at a speed of 7% of the speed of light, and we've got to determine the speed of the alpha particles. We're given the speed of light, so if we do the speed of light times 7%, which is 7 out of 100, that gives us an answer of 21 million meters per second. Now we have figure 10, which represents two solid spheres, one of hydrogen and one of magnesium. A hydrogen atom, we're told, has a radius of 2.5 times 10 to the minus 11 meters. And we've got to determine the radius of a magnesium atom by using a comparison of our hydrogen. So if we measure our hydrogen to start with, we can see the hydrogen is 0.9. So if we divide that by 2, because that's the diameter, it gives us a radius of 0.45. Now, if we look at the diameter of the magnesium now, we have 5.6, and again divide it by 2 to get the radius, and that gives us 2.8. So to work out how much bigger the magnesium is compared to our hydrogen, we can do 2.8 divided by 0.45, and that gives us an answer of 6.2. Now, what that means is the radius of the magnesium is going to be 6.2 times bigger than the radius of the hydrogen, which was 2.5 times 10 to the minus 11. We will get an answer of 1.6 times 10 to the minus 10. So the first thing you would do, you would measure the mass of the irregular object using a balance. Fill a Eureka can with water until no water is being released. You would then slowly put the object into the water, and you could tie a piece of string around it to do this, and you will collect the water that is displaced in the measuring cylinder. The volume of the water displaced is equal to the volume of the irregular object. You would then use the equation density is mass divided by volume to work out the density of the irregular object. Okay, another student did a similar experiment. He determined the density of 5 common plastics. So we've got acrylic, nylon, polyester, polystyrene, and PVC. And we've got figure 12, which shows the results plotted on a bar graph. So these were the two that were given. So the first question was to write the correct scales on the y-axis. So we did this by knowing that the nylon was 1,000, so that had to be 1,000 there. And we know that acrylic is 1,200. So we know that we've got 4 small squares there, which must equal 200, which means each small square must be 50. So we can use that to plot our axes, our y-axis there. Then we plotted the remaining different bars for the different materials. The student is given a piece of plastic material. The student determined the density of the material 3 times. So we've got 1, 2, 3 results there. And we've got to determine the uncertainty in the student's results. So the uncertainty is worked out by the range divided by 2. And if we calculate the range, that would be 1,120, take away 960, which is our smallest result, and we divide our answer by 2. And when we calculate that out, we get an answer of 80 kilograms per meter cubed.